Hey guys, I've had this set running for a few hours and it's working fairly well, but there are a few nagging issues I'd like to deal with, if possible. One is, the picture tube is the original and it's a little on the dim side, so I've got to have the brightness turned up fairly high, which makes these retrace lines really noticeable, so I want to try to eliminate those. And got those damn vertical bars on the left, just like the other sets. I want to see if I get rid of those. Just so happens that there was an awesome post by Video Karma member mbear2k of service tips, tricks, hints, whatever you want to call it, for Admiral sets. And I guess he's got it for other brands as well, and he'll be scanning and posting those later. But for now, I've got the Admiral. I found these two pages to be of particular interest for this set. This section, removing retrace lines for all these chassis, including the 21B1, which is what this set is. They tell you exactly what to do right there. Connect a 270K half-watt resistor and a capacitor, 0.05 microfarad cap. I tell you exactly where to connect it up. So I want to give that a try. And two, minimizing vertical bars. This is the same info that I've showed during my 16R11 restoration about a couple things to try about relocating some wires so that they don't pick up any interference, and adjust the horizontal drive and so on. And if all those fail, they mention this filter that you could install. The other document that I had only mentioned a part number for the filter. This one goes a little bit further. The filter consists of a 680 ohm 2-watt resistor in parallel with a 0.0022 microfarad capacitor and an RF choke, L405, part number 73B8-3. Now there's the problem. So I know the resistor and capacitor, no problem, but I don't have a value for that RF choke. At any rate, let's start out with the retrace line elimination. That's fairly straightforward. Oh, and there was a vertical line visible before. I got rid of that by adjusting the horizontal drive. That's a trimmer cap on the back of the set. I made the modifications as indicated to eliminate the retrace lines. This green wire here goes to pin 2 on the CRT socket. Normally it would go right to this terminal, which goes to the brightness control. Here's a 270K resistor I put in series, and then you're supposed to attach a capacitor to that grid lead over to this point, which picks off a signal from the vertical oscillator. So the idea is this will supply a pulse through this capacitor to the grid, which will cut off the picture tube during the retrace interval, which will hopefully eliminate that line. So let's power this set up and see if it actually works. If it does, I'll clean this up a bit neater. Let's see, I'll turn the brightness up all the way. Hey, I'll be. Looks like they're completely gone. Cool. Something else I've noticed that's kind of annoying is that if you adjust the focus seat, the picture's clear in the center and on the left, it's blurry on the right. It's a little blurry there. Might have to do with the yoke or the focus coil. I might have to physically adjust them a little bit. But anyway, the retrace lines are gone. Cool. I hooked up my scope to the grid on the horizontal output tube, and if you look close, see how there's a little bit of ripple or ringing on that curve? I think that corresponds to the bars we're seeing. If you look on the service info, this is what they show. Nice and smooth. We've got some jagged lines. Now also, the signal level's much too high. They show 60 volts peak to peak, whereas I've got like over 150. This is a 50 volt scale, 50 volts per division. So we got 1, 2, 3, so like 160, 170 volts, so that's not right. So I'm going to start backtracking and see what the heck is going on. There's a control on the back of most sets called horizontal drive. That's what's in this hole here. It's a trimmer capacitor, and that controls how much drive gets through to the horizontal output. It's a trimmer right there. So I just adjusted that, tightened it down all the way, and that dropped the signal level down quite a bit. So I dropped the scale on my scope down to 20 volts per division, so now we're 1, 2, 3, 4. Still over 80 volts, but it's a lot better. So I cut it about in half. We've still got some ripples down here though, so I will keep investigating. Here's a schematic showing a later production run of this chassis, and what do you know? There's the filter right there in the schematic. So they added this filter to later production runs. So they must have known it was a problem, probably a design flaw. So we know the resistor should be 680 ohm, 2 watt, and the capacitor is 0.0068, but we don't know what L406 is. And this is installed between the plate of the damper and the flyback. Well, I found an article on the Antique Radio Forum. Somebody had exactly the same problem, and they also found the schematic. And what he did is he took an inductor he happened to have lying around and then fiddled around with different capacitor values until to reduce that ripple. I take a little bit more of a scientific approach though. So I have my scope probe just lying here on top of the yoke, which is enough for my scope to pick up a signal. And because I have this fancy scope here, I have storage capability, so every time I hit run, it'll just take a snapshot. Once I got this snapshot, I can put it the measurement mode in time and use cursors, which are these lines here I can move around. So I can figure out the frequency of this ringing, which is what we're trying to get rid of. So if I put one cursor on one peak, put the other cursor on another peak, we get a frequency in the delta time. Now he guesstimated the frequency was about 180 kilohertz, and that's just about what I'm getting too. So if I know the capacitor is supposed to be 0.0068, and I know the frequency is around 180 kilohertz, I can plug those into a formula and figure out what the inductance value is for parallel resonance. I went online and Googled for parallel LC calculator and found this website called whatcircuits.com, and it has a nifty little calculator here where if you know two of these three values, L inductance, C capacitance, or F frequency, you can get the third value. So we know it's 180 kilohertz or 0.18 megahertz, and the capacitance, as stated on the schematic, is 0.0068 microfarads, also same as 6800 picofarads. And if we calculate, we get, rounding up, 115 microhenries. If I flip over to Mouser Electronics and go to all products, passive components, inductors, and put in our parameters here. There's different package termination styles. We want axial. That means it's actually got leads coming out. They also have surface mount, chassis mount, screw mount, and so on. We just want plain old axial mount. Don't care really about tolerance. So let's see if we can actually get 115 microhenries. And we do. However, the combination of 115 microhenries and axial produces no results. There's kind of a standard numbering scheme in component values, and some values are more standardized, or certainly are more common than others, like 100 or 110 or 120. So let's see, we got 27 at 110. And if we look, we see that they're all non-stock except for the first two. So we could go with one of these, but I happen to know that 120 is a more common value than 110. In other words, there are more manufacturing options. So let's check out 120. Oh, by the way, you can also select a range in Mouser, so I could go from 110 to 120 and highlight the whole block. In fact, let's just do that. You can also check the box up here for stock, so we're only going to get results that they actually have in stock ready to ship right now. Alright. Now you can see we got a bunch of results here, and the price on some of these is significantly more than others. Like this first one is $4.20 for one inductor. I suspect that's because it has large power handling capabilities. It's labeled as a power inductor. Well, we don't have anywhere near that kind of requirements. I doubt there's more than a few milliamps going through here. In fact, we kind of know because there's also a 680 ohm 2-watt resistor in this circuit. And if you work out the math, to get 2 watts through 680 ohms, that's like 54 milliamps or thereabouts. So I don't think we're dealing with a whole lot of power in this little filter circuit. So J.W. Miller, that's a company I certainly recognize. Same with Burns. I like to go with name brands when possible. Now here's one I like. 18 cents. It's a lot better than $4.20 or $1.23. So let's pull up the data sheet on those. We see they have a couple different families here. That the 77F, the 78F, conformal coated chokes. And these are all just pennies, 18 cents basically. And then here are some that are $1.04, $1.63. I think the reason these cost more is their military spec, whereas these are commercial, which is fine for me. And if we go down 120 microhenries, it can handle 160 milliamps, 18 cents. That sounds like a winner to me, so I'm going to go ahead and order a bunch of those. While I wait for those inductors to arrive, there's another issue I want to tackle, and that's the washed out look on this picture. At first I thought maybe it's just the picture tube. This is possibly the original picture tube, and it's not aluminized like the last set I worked on, so it's not going to be quite as bright or crisp. But it turns out that actually it can get fairly bright. It's just the contrast is horrible. You really have to have the contrast up all the way and keep the brightness down fairly low to have a watchable picture. So I thought I'd take a look at the contrast circuitry and see what's going on there. Turns out the contrast on this set's really simple. I call it a picture control. Just a potentiometer between ground and the cathode and one of the elements inside the tube. I think that might be the suppressor. Normally the contrast control controls gain in the IF stages or on the AGC bus, but this now just controls the gain on the final video amp. So I took out the potentiometer, and it does range from 0 to 1500 more or less. So I thought I'd take a look at the signals around this tube. To do that I had to pull out a different schematic, one that actually shows waveforms. And on the grid of that tube coming out of the IF stage, they show about 1.5 volts peak to peak. And what do I have? Well, let's see. One, two, three, four. So this lead right here, this wire, is the output of the IF stages, and that's the final video amp tube right down there, 6AC7. At that point, I've only got about 1 volt peak to peak, not 1.5. Which would be 3 squares. I've got this at 0.5 volt per division. And worse yet, if you look at the output of the video amp, it should be about 60 volts peak to peak. And I've only got about 30 or 40. So I don't think it's a problem with the contrast control, it's a problem with the gain. Now, I've been going through this IF stage and I've been replacing the parts, but I have not aligned it yet. So I'm hoping maybe the alignment's really off in either the IF or the tuner, which is killing the gain. And once I get that straightened out, the signal going to the picture tube will be larger in amplitude, which will provide more contrast in the picture. I had previously recapped the IF section, but now I'm going through it and checking the resistors in more detail. The set's playing alright, but the picture looks really washed out. It might just be the nature of the picture tube being the original, and that's just as good as it's going to get. But I'm hoping that maybe I can find some out of tolerance parts in here, increase the gain, increase the contrast. I also might try rejuvenating the picture tube as a last resort. So I started checking the resistors in here, and just like in all the Admiral sets I've worked on recently, quite a few of them are way out of tolerance. It's supposed to be a 1K resistor down in here, and what do we have? Almost double that, 1.93K. And I find the same things on numerous other resistors. Started replacing them over here. A few more to go through in here, and then up in here. I've also come across quite a few where they had a double up resistors. Like there's a couple 180Ks in series up there, a couple 33 ohm in series down here, and those are the original. I think that at the factory they just didn't have the right values. I think that's supposed to be a 68 ohm. Instead they doubled up two 33s to make a 66. I'll be replacing that with the value indicated on the schematic. And shortly we'll see what difference this makes. I was trying to go through the alignment procedure, but I was getting a lot of noise on my scope, and I think I've isolated it down to this high voltage area being filthy. I think there's a lot of corona discharge going on down here, so I'm going to give this a good cleaning. As you can see, it's quite dirty. I used a soft brush, compressed air, Q-tips, mineral spirits, and so on, and I got it looking a lot better now. I'll reinstall the high voltage cage, and hopefully that will improve things so I can carry on with the alignments. Before I reinstalled the high voltage cage, I gave it a wipe down with some liquid rust remover and then polished it with some metal polish. While reinstalling it, I noticed a pretty bad design flaw. Here's where the AC power comes in. Originally there would have been something like this riveted right to the high voltage cage, but that's long since rotted away, so I've been using this cheater cord. Well, what's right on the other side of those power connectors? The flyback, and in particular this high voltage donut here. So what I noticed is that the AC power wire had shorted to that high voltage donut right about in here. There was a nasty burn in the insulation here, and there was a melted chunk out of the flyback. So I put some heat shrink tubing over the AC wires, and I'm keeping them tucked out of the way. And I should go back and put some type of high voltage insulator on that donut right about there. Luckily there doesn't appear to be any damage because the flyback does seem to be operating correctly. I took a look at some of my other 21B1 chassis sets of later production runs, and what do you know? They relocated the AC power plug from here over to here. So I imagine this wasn't the only set to have problems with that configuration. While working back here, I noticed a couple other things. One, the base was loose, so I used some good old Permatex windshield and glass sealer. Put a bead around the base, let it set overnight, and that's on there nice and solid now. It's a little bit of wiggle, but that's because the silicone has some give to it, but I think that's a good thing. It's a nice solid bond, a little bit of flexibility, means it's less likely to crack off. And the last thing I noticed is that this ion trap has some wiggle to it. I loosened it up while I was gluing this down, but even when it's tightened down, because it is only a single pole magnet, unlike these dual pole magnet guys, so there's only one point where it's actually got some friction holding it down. So no matter how tight you tighten this, it still has some wiggle. Well, if you recall, on the right side of the screen over here, it was blurry when you had a good focus on the other side of the set. I noticed that when I would maneuver this just a little bit, the brightness wouldn't change much, but the focus would change quite a bit. So I think by manipulating this, we can get a clear, even focus across the whole screen. Next I'm going to fool around with that and try to go through the alignment process now that I've got this high voltage area cleaned up. I got the filter components and went ahead and installed it. And here's the set playing again with all the tweaks up to date. So got the retrace lines eliminated, got the filter in place, got the ion trap adjusted, the flyback cage cleaned up. I did a quick alignment, but I do want to go back and through and do it again because I still think I can get a little bit better. So, I am getting better focus now on the right hand side. And I think the picture is looking better in terms of the contrast level, but it's not quite as crisp as I'd like. That's why I want to go through the alignment again. Now, as for those vertical bars, they are reduced, but they are still present. So what I think I need to do on that is tweak the values. Now if you recall, the calculation came out to 115 microhenries, but I used 120. Plus there's always some tolerance with the component values, and I don't know that the frequency is exactly 180 kilohertz, so I think the thing to do there is to put a variable capacitor in the circuit. Since I have a fixed inductor, the easiest thing to vary is the capacitor.
Prepare my back.
But we're getting there. It's getting pretty close.
Be best friends. I'm sorry. And now he's lost. He's not lost. I've hidden him into the fire at the spa. Well, you didn't.
Wake up and smell the daisies, my fairy friend. If Sapphira finds Ned, she will so bust him.
See these streaks up here? That's from having the contrast up too high. But if I back off the contrast, the picture gets faded. That's the main thing I still want to try fixing. Because this picture tube, as I was saying, is actually pretty bright. It's just the contrast is not what it should be.
Sir, I found her walking the streets.
Here's what those 120 microhenry inductors actually look like. Quite small. And here's where I tacked in the filter. It's just temporary until I get this working to my satisfaction. So here's the inductor, there's a 680 ohm resistor, and there's the 0.0068 microfarad cap. One thing I thought was curious as I was editing the video before I post this to YouTube is I noticed that the first service hints I looked at talked about the capacitor being 0.0022. But later in the production schematic they show up 0.0068. So I definitely want to play around with that capacitor value. If you're wondering how this works, an inductor and a capacitor in parallel in the path of a signal will act as a notch filter at the resonant frequency. So the idea is this should knock down that 180 kilohertz signal but allow other frequencies to pass. However, it does have that 680 ohm resistor in there, which is a way for the signal to sneak through at any frequency. So I've got to figure that they knew what they were doing back then, so I'll stick to the original values as best I can determine them. Once I do get this working well, I think I'll use one of these spare pins on this tube over here as a tie point so I don't have this stuff flopping around. Well, I'm going to finish off this video segment here, and I really hope the next part will be the last. So I'm going to fiddle around with that. I'm going to go through an alignment one more time, and then let's take a look at the cabinet.